So today we're going to finish up section 5. This is the last section that you need to know for the test. Today we're going to be solving equations with complex numbers. So we've already learned 4 methods for solving quadratics. We learned the even root or the square root method. We learned how to factor them, complete the square, and quadratic formula. We're doing exactly the same process, but now, once we do this, we're going to end up with a negative square root. So the only difference is we're going to get i's in our answer. So all of the same techniques from section 1.4, the only difference now is we get an I. So let's go ahead and take a look at some examples. So for number 1, it says, x minus 2 squared equals negative 20. This one is set up to use the square root method. So that's what I'm going to do. I'm going to square root both sides. So x minus 2 squared minus 20. It's my square root, or my square term is already isolated. So I can just square root both sides. This will come out. This ends up being plus and minus. And when I square root that, an I is going to come out. And then I'm left with 20. However, I need to break down the 20 because I need to leave it in simplest radical form. So let me go ahead and do a factor tree for 20. I'm going to do 4 and 5. You could do 2 and 10, but you got to keep going. 4 is a perfect square, so it becomes 2 radical 5. So now I have x minus 2 plus or minus I, and actually I'm going to put it as 2i radical 5. I need to add the 2 to isolate x, and my final answer, x equals 2 plus or minus 2i radical 5. And you're done. Number 2, same thing. We're just using the square root method. So I'm going to square root both sides on number 2. 3x minus 1 squared. My square term is isolated. So just let's square root it. Square root. The 3x minus 1 comes out. I'm going to go ahead and pull the I out and leave the positive 48 in there. I have to leave it in simplest radical form, so I need to break down my 48. I'm going to do 16 and 3. You could do 6 and 8, but you got to keep breaking it down. I always try to find the largest perfect square. So then I'm now left with 3x minus 1 equals 4i plus or minus. This had a plus or minus. Radical 3. And then I'm going to add the 1. I'm going to start to run out of room here. So then I'm left with 3x equals 1 plus or minus 4i radical 3. And now I need to divide both sides by 3. So my final answer to this one is going to be 1 plus or minus 4i square root of 3 over 3. Now, keep in mind you might see this pulled apart on maybe a standardized test. You might see it as 1/3 plus or minus 4i radical 3 over 3. Sometimes they'll separate the fraction. Either answer here is acceptable. Okay, number 3, for this one, if you take a look and you think, let me see if I can factor it. Well, there aren't any factors of 5 that will give me 1. So at this point on this one, since it can't be factored, we have to use either completing the square or quadratic formula. And again, on the test on Thursday, some of the questions I'm going to specifically tell you, you must solve this using completing the square, or you must use this using quadratic formula. If you do not follow the directions, even though you get the right answer, you get it wrong. So the test will have a specific instruction that will tell you how to do it. Technically, for any quadratic, you can use the quadratic formula if that's what you're more comfortable with. However, I'm going to want to see you demonstrate completing the square, factoring, square root. I'm going to tell you specifically how to solve it. So for this one, I'm going to do it with completing the square. You can also do quadratic formula. Because it didn't specify, you have options. But completing the square always tends to be the more difficult method. So let me go ahead and practice that with you. So remember, for completing the square, you need to check that the number in front of x squared is 1. It is. So now I'm going to move the constant. And I get x squared plus x, leave the blank space, equals -5. I now take the b term, and I need to divide it by 2 and square it. My b term is 1. So 1 divided by 2 is 1/2 squared, and that's 1/4. So in here, I'm going to put 1/2 squared. Over here, I'm going to put plus 1/4. I need to factor this side. So this becomes x plus 1/2 squared. Over here, I need to add this. So it's really -5 over 1 plus 1/4. I need a common denominator. I'm going to change the -5 and make it -20 over 4 plus 1/4. And then when I combine that, it ends up being -19 over 4. So that's what I get when I add that. And now I can apply the square root method. So square root this side, x plus 1/2 comes out. I could treat this as two different radicals, like I could do the square root of -19 over the square root of 4. So this becomes plus or minus I square root of 19 over 2. I need to move the 1/2. X equals -1/2 plus or minus I square root 19 over 2. If you want to combine it, so it's just one fraction, plus or minus, and then just put a 1, just a single 2 in the denominator. Either answer is acceptable. Number 4. This one I'm also going to solve with completing the square. It can't be factored. There aren't any factors of 10, positive 10, that will give me positive 3. If it were a -10, it could be factored. But this one can't be factored, so I'm going to do completing the square. You could also do quadratic formula. So subtract 10. X squared plus 3x, leave a blank space, equals -10. I'm now going to take the b term, divide it by 2, and square it. So I'm going to be adding 9 over 4 over here, but in here I'm going to put the 3 over 2 squared. I need to factor the trinomial. It factors into x plus 3 over 2 squared. I need to add -10 plus 9 over 4. I need a common denominator. I'm going to change -10 into -40 over 4. I now can add these, and I get -31 over 4. I need to use my square root method, square root both sides. This drops out, x plus 3 over 2. Again, I can treat these separately, so plus or minus, I always put that too tight, plus or minus I square root of 31 over 2. I need to move the 3 over 2. X equals -3 over 2 plus or minus I square root 31 over 2. If you want to leave it pulled apart, that's fine. Or combine it so it only has a single 2 in the denominator. Both the answers are acceptable. When you're doing this in the homework tonight, just read how WebAssign wants you to enter it, if they want you to separate the two answers with a comma. Because remember, you really have -3 minus I radical 31, and then here -3 plus I radical 31 over 2. So just pay attention in the question to see how WebAssign wants you to enter it. Everybody good here? Let's try the next one. We're going to use the square root method. Now, you might look at this and say, oh, wait, this is two perfect squares, But remember, there's no such thing as the sum of two squares, so I'm going to use my square root method. I'm going to subtract 25 from both sides. X squared equals negative 25, and now I square root both sides. So x is equal to, and then this is negative, so plus and minus 5i. Number 6, you might look at it and say, wait, can I factor it? No, there aren't any factors in 9 that give me 2. So for this one, just to change it up, I'm going to use quadratic formula. So a equals 1, b equals 2, c equals 9. Let's plug it into the formula. So we get negative 2 plus or minus 2 squared minus 4 times a times c, all under the radical, divided by 2 times a. Negative 2 plus or minus 4 minus 36, because negative 4 times 1 times 9, negative 36. 2 times 1 is 2. And now I can add what's under the radical, and I get negative 32. Do not be tempted to simplify these 2's yet. You need to break down the radical first. So I'm going to break down my radical, 32. I can break it down into 16 times 2. And just remember, we had a negative here. So if you want to think of it like this becomes 4i radical 2. So now I get negative 2 plus or minus 4i square root of 2 over 2. Now I can simplify. So I'm going to simplify the 2's. These are going to become 1's. And then 2 goes into 4 twice. So my final answer here is going to be negative 1 plus or minus 2i square root 2. Number 7, I'm going to use the square root method, or the last 2 on your notes, and I'm going to add 2 more questions. I'm going to use the square root method for both of the last 2. So for number 7, again, it looks like it's 2 perfect squares, but there's no such thing as the sum of 2 squares. So I'm going to subtract 9. 25x squared equals negative 9. I want to isolate the square term, so I'm going to divide by 25. X squared equals negative 9 over 25. Square root both sides. X is equal to plus and minus 3i over 5. If you want to put 3/5 and then the I behind it, you can do that as well, but it's plus minus. Yes?
Can you go back to the previous one?
Mm-hmm. All right. Last one in your notes, and then I'm going to add 2 more. Yes?
So how do you know when to use the different formulas?
When what?
When to use the different formulas? When to use quadratic, when to do, I don't remember what each of them is called.
Okay, so technically, if you're taking a PSAT or an SAT and they just say solve and it's a quadratic, it's got an x squared, technically you could use the quadratic formula for every single problem. Honestly, if it's a trinomial and it can be factored, factoring is the fastest way. That's the way that I can do it the fastest. Quadratic formula is pretty quick, but you got to be very careful with your signs. One little sign mistake when you're doing order of operations and your answer is going to be totally wrong. On the test, I am going to specify, and I'm going to say, solve this problem using completing the square. Solve this problem using factoring. I'm going to specify. If it doesn't say which method to use, if it just says solve, you can choose. Yes?
Can we check with another form?
Absolutely. The test is kind of long, so you're going to have to work rapidly, okay? I wouldn't check until the end, but absolutely, you can check using another form. All right, last one in your notes, but I'm going to add 2 cubes. So let's go ahead, and I'm going to use the square root method again. So I'm going to divide by 3. X minus 1 squared equals negative 16 over 3. I'm going to use the square root method here. Square root both sides because my square term was isolated. X minus 1. And again, I can treat this as a negative 16 over the square root of 3. The numerator is a perfect square, so this becomes a 4i over radical 3. I need to rationalize that. I can never ever leave a radical in the bottom of my fraction. So 4i over square root 3 to rationalize. I'm going to multiply it to make it a perfect square by itself. And then this becomes 4i radical 3 over 3. So that is what this now simplifies after it's been rationalized. I still have the x minus 1 over here, so I need to move the 1. And final answer here is going to be x equals 1 plus or minus 4i square root 3 over 3. The 3 is not under that 1. Now, if you want to put it all in 1, you got to get a common denominator here. And you could also change it up and say it's 3 plus or minus 4i radical 3 over 3. But you could have just left it as that. Now, I'm going to do 2 perfect cubes because you will have a cube that you'll have to solve. So you need to know your SOAP pattern. Everybody good here? Now, I know the announcement on Canvas says that I think 1, 2, I think was rational. You may not get a rational equation on the test. It may be just more focused on 1.4 and 1.5. So on the imaginaries, the quadratics, and the cubes. But I'll confirm that with you tomorrow. All right. Now this was not in your notes. This was just added because this is on the test. So we're going to solve the equation. So this is a perfect cube. We're bringing back our SOAP pattern. So I need to cube root the x to the third, cube root the 64. This is going to turn into, and this is the pattern, so x minus 4, then square the x, multiply the x and the 4 with opposite sign, and then square the 4, always positive. Now, before, when you were factoring these cubes, remember the trinomial could never have been solved before. Now that we know the quadratic formula and we know how to deal with imaginaries, we're going to actually solve that trinomial. So we're going to take each one. It's going to have this, whenever you factor a cube, it's always going to have a real answer and an imaginary answer. It's going to have 2 answers. So the first one, the real, is found by just taking the x minus 4, set that equal to 0. And my first real solution is x equals 4. I have 2 imaginary solutions. Now, remember, we can't solve the trinomial in the cube by factoring, but we can solve it by either completing the square or quadratic formula. I'm going to use the quadratic formula because what we're doing now is x squared plus 4x plus 16 equals 0. I'm going to use quadratic. A equals 1, b equals 4, c equals 16. Negative b plus or minus b squared minus 4 times a times c, all under the radical, and then 2 times 1. Negative 4 plus or minus 16, and then 4 times 16 is 64. So minus 64 over 2. Don't be tempted to simplify yet. You got to break down the radical first. Negative 4 plus or minus negative 48 over 2. Let's break down. We already did the 48, but let's do it again. So negative 1, 16, and a 3. So this becomes I, so 4i radical 3. So negative 4 plus or minus 4i radical 3 over 2. And those are your, well, we got to simplify first. Simplify. So this becomes a 2, and a 1. So negative 2 plus or minus 2i square root 3. So these are your two imaginary. So we have three solutions here. We have the real one. We have an imaginary. And then the other imaginary, 2i radical 3. So you could pull them apart if you want. I'm okay if you just left it with the plus minus on the test on Thursday. WebAssign may ask you to pull it apart. Let's do one more practicing the cube pattern, and then I'll give you back your quizzes, and then if there's time, I'll do any homework questions as well. All right, 216. 216 is a perfect cube. It's 6 times 6 times 6. So x plus 6, square the x, opposite sign, and square the 6. My real solution is found by setting x plus 6 equal to 0. So my first answer is negative 6. I now need to find the two imaginaries, and again, I'm going to do quadratic. You could do completing the square. So a is 1, b is negative 6, c is 36. So opposite of b, plus or minus, b squared minus 4 times a times c. All under the radical, 2 times a. 6, 36. 36 times 4 is 144. Subtract what's under the radical, 6 plus or minus negative 108. And now I need to, don't be tempted to simplify there. I need to break down 108. So negative 1. Let's see, 108, I can divide it by 4. Actually by 36, I think. 108 divided by 36, yes. So 108 is actually, and if you didn't catch that, you could keep breaking it down till prime, but it's actually 36 times 3. So this will become 6i radical 3. That's 108. So 6 plus or minus 6i square root 3 over 2. Now I can simplify, make that a 1, a 3, a 3. Final answer, 3 plus or minus 3i radical 3. So these are your two imaginaries, and we also had the one real. So don't forget about including on your answer line the real and the two imaginaries. So that was just a review of factoring cubes. Yes?
For the two imaginaries, can we just put like plus or minus?
Yes. So on the test, you can put plus or minus. You don't have to pull them apart. So that is it for the notes on 1.5b. So you have that homework assignment. Again, I posted 2 reviews. The 2 reviews, one says test number 3 review quadratic practice, and it asks you to do all the different methods. Same thing on the test review. And it also has the imaginaries. So those are both posted. I already posted the solutions for the quadratic practice. I'll be working on getting the solutions for the test, the other one, posted, and I'll put it in the assignment as well. So on the test, now that we've learned about imaginary numbers, it's going to say find all solutions, real and imaginary. So no longer can you say no solution when you get a negative radical. We know how to deal with negative square roots now, so whenever that happens, you're always going to have perhaps an imaginary solution.